Hello everyone, this is Mr. Schmidt again from Diamond Oaks Career Campus in our Automotive Service Technician Lab. Today we're going to talk about how to diagnose vacuum leaks. We do have a new piece of equipment we're going to demonstrate for you today. This is from Snap-on. It is the Smart Smoke generator. We use this for checking for vacuum leaks, for things in the evap system, for anything that holds vacuum or uses pressure. This way we can check to see if any hoses are broken or if we have any leaks in general. So the car that we're using this on is a late 1985 Porsche 944. This is one of my personal vehicles I brought in for my students to work on. So what we're going to do, we're going to show you how this machine works, and we're going to do a quick demo on it. So we have our current machine, we have our shop air set up, we have our 12-volt battery connections, we have our hose that is going to generate our smoke. So first thing we want to do is we want to hook up our battery. This does have a reverse polarity protection. If you do not have your positive and ground hooked up properly, this machine will let you know. Every time we turn the machine on, it's going to go through a self-calibration method. This is calibrated from the factory. We don't have to do a lot with it. There are some features that we're going to do. This does tell us our leak size. We can see total volume of air flown through the machine. And we can check pressure and vacuum. So right now, we have our display set on the orifice leak size. This is a leak that's going to be in our hose or our vacuum line. So this will actually give us a size measurement for how big our leak is. We can select different sizes. If we have a very large leak, 40 thousandths is a large leak, 10 thousandths is a very small leak. So if we have a fine leak or a small leak in our evap system, we can set this up for a small leak, and this will do a pass-fail check. So we're going to just pick 20 thousandths. It'll turn on to 20 thousandths every time we turn our machine on. We have our shop air on. Our shop air is connected. We have everything hooked up, so we hit our start button. So it says full because we have a full leak. And then we can see very faintly, as soon as this warms up and starts to make smoke, we're going to have smoke come out of our supply tube. So we're going to hit our button here, we're going to turn it all the way off, and it stops the flow of our smoke. So what we have here, we have a car, head gasket, everything was done on it, but when we start it after our repair, it starts and stalls repeatedly. So we're going to check it for vacuum leaks. So we have additional sources. We have our fuel pressure regulator, we have our fuel dampener, we have our throttle body with our various hoses on it. But we're going to pick one of the easy ones because it does all connect to each other. So we're going to take this here. We're going to take the hose off of our fuel dampener for our vacuum supply. And we're going to put this hose in from our smoke generator. Now, before we turn this on, here's something I'm going to show you. We want to block off all open induction system hoses. Don't forget to take this back out when you're done. If it's too small and we get it stuck in our boot, this will cause a no-start condition because it won't be pulling air in past our airflow meter. So what this does is it creates a solid cap instead of letting it breathe and pump smoke out back through our air filter. We only want the smoke to be in on our induction side. That way we can find our leak. So we have our smoke generator hooked up. We're going to go ahead and we're going to turn this on. And you can see we have a leak that's 35 thousandths. So that means we have a substantial leak somewhere here. So now we have to wait for the smoke to show up. So you can see here we got little wisps of smoke. So let's get our flashlight out, take a look. Let me turn that down so it's easier to see. So we have smoke coming out from under our intake plenum. And we're going to look a little bit more. We're going to see if we can see it. Let's take a look. And we'll see if we can see where it's coming from. So we are leaking smoke way down here under our intake manifold. So chances are one of these hoses, because this is a car that's almost 40 years old, some of these hoses have a split in them. And let me just look around a little bit more. And I can see it. It is very faint. I'm going to try to zoom in on it here for you. I don't think it will let me. So all the way down here, we have a hose clamp, and our hose clamp is tied to the bottom of our intake manifold. That hose comes up here to our idle air control valve. So that explains why our car is stalling after we have done our head gasket job. So once we're done and we find our leak, we've isolated it, we come up to our machine and we turn it all the way off. And now it says off. Okay, so now our machine's off. We're no longer producing any smoke. We have identified our leak using our new Snap-on Smart Smoke. And then now we're going to remove the intake plenum and we're going to replace the hoses underneath. And that should rectify all of our issues. So again, I want to thank you for watching this quick tutorial video. This is just one way how we can use our Snap-on Smart Smoke machine to check for vacuum leaks. So we can check for leaks in our evap system. We can check for any vacuum control, any type of intake leak, anything that operates with vacuum or pressure. We can use those. We just have to find the accurate supply port to tie into, just like we did here, and just make sure it's attached to the relevant system. We have different adapters, such as these. If we had a leak in our evap system as part of our fuel tank, we have this cone adapter that we can put in the fill neck of the gas tank and actually pump smoke into the entire fuel tank area. So that way, if we had a customer maybe with a fuel smell, or if we had fault codes to trace, we could do that. We have larger ones for bigger intakes. We have various adapters. We have a standard adapter for evap testing. This screws onto a test port that most modern vehicles have on it. And naturally, our car from the 80s does not have that. So we will follow up with a progress report on this vehicle when it is fixed, and it will be going over to our body shop program that will be prepared to finish it this school year. Again, this is Eric Schmidt at Diamond Oaks Career Campus, and thank you for watching.